Good afternoon, everyone, and a very warm welcome to today's session hosted by AWS User Group Dehradun. My name is Aditya Pandey, and I am the AWS User Group leader for Dehradun. And it's wonderful to see so many of you joining us today. Today's session is extra special because we are celebrating International Women's Day. This day is about recognizing the incredible contributions of women across industries, including technology and cloud computing. At AWS User Group Dehradun, we strongly believe in creating a community that encourages learning, collaboration, and inclusivity for everyone. And we are really fortunate to have an amazing speaker with us today. Our speaker, Pallavi Srivastava, is a principal engineer at NetWest with extensive experience in building scalable systems and working with modern cloud technologies. She brings a wealth of practical knowledge and real world experience that I am sure will be incredibly valuable for all of us today. Today, she will be speaking about deploying serverless AI applications on AWS, where we will explore how AI applications can be built and deployed efficiently using serverless architectures. Before we begin, just a quick note for everyone. Please feel free to drop your questions in the chat during the session, and we will try to take them towards the end during the Q&A. And with that, I am really excited to hand over the session to Pallavi. Pallavi, the stage is all yours.
Thanks a lot, Aditya. And good afternoon, everyone. Welcome. I'm Pallavi Srivastava. As Aditya mentioned, um, I'm a principal engineer and cloud and AI architect. Today, we are going to spend 90 minutes together on something I'm genuinely passionate about, and that is deploying AI applications on AWS using serverless architecture. Just before we dive in, a quick shout out. Today is International Women's Day, and the fact that we have so many of you professionals here learning and building together, this is exactly the kind of energy this day deserves, right? So let's make it count. And a quick note on how we are going to run this session. Don't worry, it's not going to be theory. Everything I show you today is based on real architecture decisions, real trade offs, and the real code. So we have a live demo as well towards the end where I'll show you how I have built and deployed an actual AI application on AWS. If something breaks, even better, that's a lesson two, and let's sort it out together. So let's quickly get started. A quick intro from my side would be that I've spent days in designing and shipping production AI systems. I have architected real world use cases as a solutions architect, and I am working currently extensively with generative AI, LLMs, and data, serverless, and all these technologies. And I've spent almost 8.5 years in AWS, and currently I'm a principal engineer at NatWest. Outside of my day job, I have recently started a content channel on YouTube, Instagram, where I break down architectures as well and tell you about the tools which you can benefit, and also the lessons which I wish someone had told me earlier. About today, the agenda we are going to cover is just divided into different sections, and it is time so that we don't run over. And we are going to start with the why, like why serverless and AI together is such a powerful combination, and what are the numbers actually looking like in production, not exactly in theory. So we will go deep into 5 reference architecture patterns which are very common and many industries are using it, and I will share some actual production blueprints. We will also cover the AWS services stack, the deployment, DevOps practices. Then we will hit the live demo where we'll spend time building a real document intelligence API from scratch. At the end, we'll take some Q&A, and we'll also see what are the pitfalls of current design which are actually running, and how you can prevent your architectures from that. So let's get started. And what you can see on the screen is the actual numbers. 93% of AI workloads are actually bursty. Now, think about it like your AI gets hammered during business hours, during campaigns, or let's say at the end of the month, and then it sits idle. If you run this kind of system on an EC2, you're paying for idle compute that is running for 24 by 7, right? So even if the traffic is at a particular time of the day, at a particular time of the month or year, let's say for a specific campaign, you still have to pay for the complete time if you run it on EC2s, right? With serverless, when there is no traffic, your cost becomes zero. It's actually zero because it's pay as you go. So whenever a request hits, the billing model starts. So that's how it's actually working. It's not marketing, that's the actual billing model which serverless operates on. The auto scaling story is actually equally compelling. That let's say you have a bursty traffic where suddenly there's a lot of traffic coming for your website. You don't have to manually scale anything because serverless takes care of that. For example, in AWS, you have lambda functions, and lambda concurrency can be managed in advance if you know that this is the limit which has to be reached. So you can directly get the help from AWS and get that sorted, and it can scale automatically. You don't have to worry. So you can go from one request per second to 10,000, and you don't need to make any changes in the code, in the infrastructure. Let's say no emergency at 3 a.m. phone calls, right, to spin up more instances. So that's the ops overhead which is being reduced when you start using serverless. The time, which is operational time, that is 80% of the time is spent in managing all of this, can be reduced, and this time can be given back to the developers or the actual leaders who are thinking of building something new. So no patching, no capacity planning, no on-call rotations for these kind of requests and the workloads. So these are the real numbers, and there is a consistent pattern which we see, that teams who moving AI workloads from traditional infrastructure to serverless are actually benefiting from this kind of operating model. With that, I would also like to mention that serverless AI is not the right choice for all of those workloads. So just being upfront about it, because I think it's important to understand in the beginning itself that it's not always the answer. So let's say if you have sustained high throughput inference where you are expecting hundreds of requests per second constantly, you will hit the lambda concurrency limits, and the economics can also flip. The cost will also raise, right? Now, if you need sub 100 millisecond latency, P99 latency with absolute consistency, then provision concurrency in Lambda can help, but it will not guarantee, right? So if you're hosting a fine tuning model with custom weights, you can't do that in Lambda. For that, there is a specific service called SageMaker, which can very well be used to perform those kind of operations. So that's why on the screen, you can see that there are specific scenarios where serverless struggles a little bit because that is the nature of how the services are built, but there are better alternatives. Just to touch base on few of those, for example, you have long running AI training jobs. For that, the specific service which you can use is SageMaker training jobs. You can use AWS batches where you have multiple workloads running. You can batch them, run them on SageMaker, do the fine tuning, model training, and other things, and then reference that models further, right? Or you need low latencies, then you also have Fargate. So if you know about containers is also a very good choice for running AI workloads in case you don't want to go serverless. And within containers also, if you want to offload the management of the specific container, you can use Fargate, where AWS manages the scaling, the patching, and other things of that particular container. We have SageMaker endpoints, right, which are very useful in case of high throughput. So that can also be used in case you don't want to use serverless. There is also, let's say you want to do some caching, state has to be maintained. In that case also, you can use ECS plus Elastic Cache. So just remember, when we are talking serverless, a request comes in that is being operated. A Lambda work, you can say Lambda environment is created, the code is executed and done. For where you have to maintain the state, right, for stateful sessions, in that case you can use ECS, where the states can be maintained throughout. Okay, so let's go ahead and look at the serverless AI stack. This is your reference architecture. This is the full production grade serverless AI stack, which is actually laid layer by layer. So you can see multiple layers in this architecture, and this is something which you can actually screenshot and you can use it repeatedly whenever you are starting to build any AI application on the cloud, right? So this is a mental model which has to be used while you're designing these systems. Let's start looking at it from left to right. So you can see the first layer is client layer. Let's say you're building an application. It can be for a web, it can be for mobile, and you might be using CLI, right? So there are different SDKs which are available. There are different REST calls which can come. So this is a client part which actually triggers the whole stack. After that, we have the API layer. So this client layer hits the API layer. API layer, we have the serverless service called API gateway becomes your front door. After API gateway, we have the orchestration. But okay, before orchestration, sorry, in the API layer itself, you also have to ensure that you have cognito or any authentication mechanism to actually authenticate the kind of requests which are coming in. If you want more protection against malicious traffic, you can use WAF as well. So once this API layer is fulfilled, the request has reached, it will then flow into the orchestration layer. Now, this is where step functions and event bridge comes in, right? They actually coordinate the workflow. They bring in different flavors of actions which has to be performed. There is also, if you're working with agents, there is agent code as well, which can be used for orchestration specific to agents. But when we are talking about the serverless stack, we can use services like step functions, event bridge, SRE or SNS, which are triggered by the API layer and orchestrating the flow. So where the request has to land up next is something which they will orchestrate. Then of course we will land up to compute, right? So in case of compute, you have lambda functions, you have containers lambda, then there are different layers which you'll have to set up, and lambda can talk further to the AI and ML layer, that is where Amazon Bedrock, cloud and Claude and other foundation models actually live. So these are the things which you can actually look for, and this is a complete layer which you need. I think this mental model will help you to create the you can say any AI application in a very useful way, and this can be applied to any cloud provider you're using. So in that case, this should be useful. Then we have a storage and data layer, which is a common layer across and will be used in different layers as well. So we have DynamoDB service, which can help you to maintain the state and the sessions. We have S3, of course. No architecture here in AWS. I think S3 is a core component where you actually store the objects, right? So the documents, the assets, if you're hosting a website, you can use S3 for that. Then we have OpenSearch. Now comes the AI part where, let's say, you have to use a vector database, you have to create embeddings. In those cases, you can use OpenSearch. Then we have Elastic Cache that is being used to do the response caching. For the security, like you have Secrets Manager if you want to keep any keys and config. There is, you can say, a kind of services which are across, again, would be CloudWatch for monitoring. Then we have X-ray tracing, we have the IAM rules, policies, etc. VPC endpoints, if you want to make any part of your application private, you can use that. Then these are actually not optional, these are something which are needed for production, right? And they are the actual difference between a demo and a real system. So everything I'm about to show you throughout this session and in the demo is a subset of this architecture. So we are bringing the flavors of API via API gateway, orchestration we are doing via SQS, SNS, then compute we are using Lambda functions, and we are using Bedrock to connect to the end foundation models. There are many which Bedrock gives an interface to. So that's how we are going to build the serverless stack. Let's move towards the pattern which we can use in our daily lives when we are building or working with the AI systems. Now, the first pattern, I think you might have already heard about it, that is RAG. And this is the most commonly deployed AI pattern in enterprise right now, and for all the good reasons, right? It solves the single biggest limitation of LLMs, that is, they don't know your data. Now, if LLMs don't know your data, it can work locally, but in production it can't, right? Because what will the LLM act for? So we need the data, right? So RAG flow is very simple. A user asks a question in natural language. We embed that question into a vector using Amazon Titan embeddings or any other embedding model. Then we open search for the most semantically relevant chunks from the document. So basically, the document is divided into different chunks. There are meanings associated with that chunk, and then at the real time, we are trying to validate or get the data from that vector store where we are storing these chunks and the embeddings. Now we retrieve the top K results. We pass those results as context to, let's say, Claude on Bedrock, which generates a grounded, accurate answer. The keyword here is grounded. The reason is LLM here, or let's say Claude, which we are talking to via Bedrock, is not making things up. It's answering based on your documents. And that's the whole point of RAG. This is a perfect use case for serverless. Why? Because each query is completely independent. Lambda spins up, it embeds, it retrieves, generates, returns, and shut down. There is zero idle cost between requests. And if you want to skip building the retrieval infrastructure yourself, you can also use Amazon Bedrock knowledge bases, which manages the entire RAG pipeline as a fully managed service for you. And that's something which you can go ahead and use. And you can notice that there are 7 AWS services in this pattern that are working together. We have API Gateway, tying it back to the previous architecture and the layers we saw. API Gateway, then we have Lambda. For vectorization, we use an embedding model. We use vector store, then we generate, right, using Bedrock Claude. We maintain the chat history. Idempotency is super important in case of production data. Then we have the source documents, which can be put into S3. So this is the whole pipeline, and this actually is a very good pattern which is being used in enterprises. I think in a very useful way, and a lot of use cases are being solved using the RAG pattern. Moving ahead, we have another pattern that is event-driven AI processing. A part of this I'm going to show in the demo as well. And this pattern is being used for document processing, image analysis, using for batch AI jobs. And the core insight is very simple. Decouple the upload from the processing. So let me walk you through what we are doing here. There is a file which lands in S3 that fires an event bridge event. Rather than Lambda picking that up directly, we put it through SQS first. And there's a reason for production. I think that's what we should understand, because SQS is a buffer. Let's say if 500 documents land at once, SQS absorbs the burst, Lambda pulls from the queue at a control rate, and if Lambda fails, the message stays in the queue, or let's say go into the dead letter queue for replaying. So you're never losing any document in that case, and Lambda can process the batch. It can then call TrExtract to extract the text, which is another AWS service. Then it can call Bedrock to analyze it. So there are some ready-made services available, right, as TextRack. So you don't have to build anything new for that. You don't have to even go to the foundation models for that. Just use TextRack. It will give you the text. Pass that text to the model via Bedrock, and Bedrock can analyze it, store the results in DynamoDB, and use SNS to notify the downstream consumer. And these are things which are pretty important, and that's how the pipeline flows. Now, there are few design decisions which I'm showing on the right, because these are super important if you're going through this event-driven AI processing pipeline. First thing, why are we choosing async and not sync, right? Because AI inference, that means inference here means that the processing time taken by the model to understand the text, process it, analyze the meaning, do the embedding chunks, and all of those things take some time. As of now, right? It's evolving, so it might be faster in future, but it can take some time. Now you cannot make a user wait for that long for a synchronous response, or so in that case what you can do is you can return a 202 immediately, that we have got it, we are processing, and let the client poll for status or receive a webhook when it's done. So via notifications, or there can be a WebSocket connection where you are just posting it, right, as it's in chatbots. Because let's say you are using ChatGPT, in that case also you're just sending a query, it takes some time, and then sends it back. Now in this case, your function can be invoked more than once for the same event, like for Lambda. So that is why idempotency is also important. So you have to store the processed IDs in DynamoDB, and that's something which we are doing in the demo as well. That let's say multiple documents are uploaded, or same document is uploaded multiple times. We don't want to run the model again and again, right? So if that document is already processed, and even if it's a duplicate event at the Lambda side, we will not face any issue because it's already processed and we are ensuring that it's a unique ID. We are keeping that in DynamoDB for managing the duplicates. Error handling, definitely you can have DL queues, you can have exponential backup for managing these kind of systems. Okay, pattern 3 and 4, I've just combined them onto one particular slide. The reason is there is a very important use case which can be done via streaming, also via multi-agent also. So with this you will be able to understand how these two are different and when to choose what. So streaming here, this is how you build the ChatGPT style experience. The key here is the Bedrock's invoke model with response stream API. What it does is, instead of waiting for the full response to generate before returning anything, you stream the tokens back to the client as they are produced. So API Gateway WebSocket gives you a persistent bidirectional connection, and Lambda streams token to the WebSocket. The client can then render those tokens. So it is a massive impact for the user perspective, and the speed is actually perceived equals to actual quality in users' mind. So it it sees that, okay, line by line we are receiving the response, and that's a good enough pattern for the user. Now let's say in case of multi-agent, right? This is where things get exciting for complex tasks, and agent is the hot word right now, everyone knows. So we have agents in Bedrock, which you can use. You can divide those into different tasks. So let's say you have a supervisor agent which is running on Bedrock agent service. It receives a task, breaks it down. It delegates to specialized sub agents. One can be research agent to find the information, one can be code agent to write or review the code, an analysis agent to interpret the data. Then the result can flow back to the supervisor agent, which actually synthesize the final answer and give it back to the user. You can also use step functions, which is ideal for orchestrating these multi-agent workflows, or you can use Bedrock Agent Core as well, which helps you to orchestrate the full path of different agents. So these are the other two patterns which are very commonly used while you're building AI applications, and that too on serverless. Okay, we have the cost optimization AI architecture as well, which is super important. So if you don't implement a cost strategy for AI workloads, your cloud bill will definitely surprise you, and in a bad way. So you have to be very careful when you are spinning up these resources as well, when you're talking to the models and other things. There are three things which can be useful. First is the model selection, and this is actually the biggest one. Not every task needs the most powerful model. Classification and routing, you can use the Claude Haiku model. It's cheaper than the other model for like Opus, based on the token which you're sending. For summarization, if you want, right, summarization and model reasoning, you can use Sonnet. For complex analysis, code generation, in that case you can use Opus. And let's say if you want to route the traffic based on task complexity, not on the convenience how you want to build it, that can also be useful. So the agent framework which we saw previously can be used in a case where, let's say, for certain kind of workloads you want to use this model A, for other kind of workloads you want to use model B or model C. That's how you can send the traffic to. Then is caching, which is the most underused layer but is super important. Bedrock prompt caching can reduce token cost by up to 90%, and that is for repeated prompt fixes. So in that case, let's say you have a knowledge based Q&A system and there are many users asking similar questions, so you can cache those answers in Elasticache. That target should be around 40% cache hit ratio in production. So if you are putting anything in production, your cache hit ratio needs to be at least 40%, and then only you'll be able to harness the benefits of cloud. Then we have some architecture controls which are also super useful, like we have the guardrails. always set the max tokens, because you don't want unconstrained generation by the models, right? It can run for hundreds of token, it can give you a lot big of paragraphs as a response, but we don't want that. You should also chunk the documents, like before sending large documents, because that will increase the token size. Maybe we do not need all parts of the documents to answer any of the user questions, so in that case the chunking will really help. There are different chunking strategies which can be used. You can definitely go ahead and use any of those. And if you're using different, let's say OpenSearch and others, there are also options you can define the strategies. Then the number at the bottom is actually real, like 100,000 AI requests per month, unoptimized versus with caching and model routing, the savings is actually 92%. So these are the actual numbers which can help you around saving a lot when you're using the AI architecture on serverless. So these cost optimized strategies can be really useful when you're actually building the AI systems on AWS. Okay. So let's go ahead and look at the core services we have, right? So let me give you a very rapid fire tour of the 6 services you need to know if you're building serverless AI on AWS. The first one being Lambda. Um, Many of you might already know it if you are already working on AWS serverless services, that the unit of work in serverless is Lambda. It's event driven. It's built per 100 millisecond up to 15 minutes execution time. There is a standard memory which you can use. You can run containers in Lambda now, which matters for AI workloads that actually have heavier dependencies, right? We also have Lambda Snap Start, which has dramatically reduced the cold start times for Java environments. So consider Lambda as a very solid compute for serverless, where can actually run your code. You don't have need to have EC2s running for a longer time if, as I said, if your workload supports the serverless use cases. Second thing, the AI foundation, we have Amazon Bedrock. This is actually a game changer. Earlier, let's say we know that there are a lot of models available in the market, right? We see every week new models are coming up. How are we going to use that model? Do we have to pull that model repo somewhere on our environment, then start using it? No, you can directly use any model using Bedrock. And that's why I'm saying that this is the game changer. So there are managed foundation models like Claude, Titan, Llama, Mistral, all can be accessed via single API. You don't have to worry about GPU provisioning. You don't have to worry about model hosting. You don't have to worry about MLOps team to actually manage these models. You just have to pay for the tokens which you're using. There are knowledge bases which gives you the managed rack. There are agents in Bedrock which gives you managed orchestration. There are guardrails which actually helps you to give the content safety of the data which you are providing. So it's actually a complete AI platform which you can use, and very useful because you can just directly access any of the models via this platform. So yeah, Bedrock is actually the AI foundation when you're building any kind of AI applications. Then we have API Gateway. So API Gateway is actually the front door. We have the REST API, we have WebSocket API. REST you can use for standard request response, WebSocket for streaming and real time. We have Lambda authorizers, which lets you plug in any authentication logic. If you have a custom authentication, in that case, you can use Lambda authentication. Otherwise, there are inbuilt authentication mechanism like IAM, JWT, others already provided within API Gateway. You have HTTP API, which is used for cost sensitive workloads. REST API is when you need richer feature sets. So there's a difference between HTTP, REST, and WebSocket APIs and the features they provide and the limits. So you can definitely go ahead and check that out. Then we have DynamoDB. So single digit millisecond latency at any scale. This is another powerful service which helps you to build the data foundation for your AI applications. It provides you on-demand capacity, which means that you pay for what you use. Perfect for bursty AI workloads. Let's say a lot of request comes in. You don't have to provision your database separately. You just use DynamoDB and your data can be handled very well. We also have DynamoDB streams enable change data capture patterns. You have TTL, which helps you let the session auto expire. So those are the things which you can use. For orchestration, we have step functions. Let's say you have a workflow engine for multi-step AI pipelines where you need retry logic, error handling. You don't have to write the code for that. Just let's say you have 5 different Lambda functions, write the step functions profile and the steps, and each step can call different Lambda functions, and that's how the workflow can be set up. And you can also have Bedrock integration. So step functions natively have integrations with Bedrock. You can invoke models directly from a state machine without even needing to build a Lambda in some cases. So if you want to have direct integration with the Bedrock, that's also which can be done. Event Bridge, another service which can be very useful. It's actually a glue of event-driven architectures. There are 100 plus AWS service integration as native event sources, schema registry for very easy discoverable. Event Bridge pipes for point-to-point integrations as well are available, which you don't have to configure any code. So these are the, you can say, the managed services which can be plugged into your AI workflow, AI system workflow, and can be easily built when you're actually building the enterprise architectures. Yes, you can build websites very easily with AI right now, but where are you going to host that website is the question. And for enterprises, knowing these services will really help you to tie it all together. Okay, this is a website, this is what it needs to do, where I'm going to store the data, which model I'm going to use, right? So those controls, if you want, these are the service which you can actually start using. A bit of deep dive into Bedrock. So it's very important to choose the right model when you're using Bedrock. There are different models available. There are more. I have not listed everything here, but a few of the models are specific. For example, Claude Haiku you can use for classification, for routing, for simple Q&A. Then you have Sonnet, Opus. So all of these have different use cases, different cost, different speed, and different context. So context is the data which you provide additionally to the model so that they can understand what you're trying to do. So basically Bedrock is where the magic happens. And if you choose the wrong model, it might become expensive, right? And this can be an expensive mistake at the end. So you just have to ensure that you choose the right model as well. Just for example, Claude Haiku is just 60 times less than Opus per token. So if you're using Opus to classify whether an email is positive or negative sentiment, that might not be a good use of your money when you're building a cost optimized architecture here. The routing strategy can change. Then there are some principles which you should know when you're talking to Bedrock, and there needs to be some prompting techniques which has to be involved. For example, you need to specify the output format. If you're asking for JSON, you have to tell the model that give that that you need the structured data in response, and that too in JSON, because by default it might not know, right? So if you use these techniques, then the responses will be very clear. You'll be able to reduce the number of retries which you're doing, and that will help the overall system. So system prompt is equal to persona constraints. User prompt should be the task. So there needs to be a different set. One is a system prompt. Let's say, let's understand it in this way with an example. The user ask, what are the leave policy, or how many leaves, or let's say the user asks how many leaves are left for me. So you have a chat bot which helps the users or the employees of your company to get specific results, and they are just asking the question. Now the leave policy question is specific to that particular user. That becomes a task for the model or for your AI application. But the system prompt, that whenever there's a leave request, where they have to go, where they have to fetch the data, and what kind of details are needed whenever such kind of question comes, becomes a system prompt. So there needs to be segregation between the system prompt and the user prompt, then only the queries which users are asking will be effective, and the response will be equally effective in that case. So we need to tell the user what kind of questions they can ask. We need to tell the system, okay, this is what needs to be done if this kind of question is being asked. So the models are intelligent enough, but in case of contextual data, a bit of context will really enrich the whole AI system. There are different prompt techniques as well, few shot prompting and others, where you can actually give some examples for the models to operate. Those kind of techniques can also be used to improve the overall strategy, and that applies to Bedrock as well. There are guardrails as well. If you can see here, there are guardrails which are very much needed in enterprises. Like we have content filters, PI detection, grounding checks. These all things are also available on Bedrock. So we have to ensure then that when we are actually using Bedrock, we are enabling all of these things and getting started with that. Okay, a quick note of on deployment before we go ahead to the demo very quickly. Um, when we are moving from development to production, it has to be safe. So moving fast without breaking things in production actually requires discipline in two areas. We have infrastructure as code and the deployment strategy. When you're talking about infrastructure as code, my honest opinion, you are building serverless AI on AWS, you can start with AWS SAM. It was specifically built for Lambda and API gateway. The template syntax is clean. You just have to initiate SAM build, SAM deploy, and it works perfectly. If you are familiar with CloudFormation, you can start with that as well. For more complex multi-service task, you can move to CDK. You can write your infrastructure in TypeScript or Python, whichever you are comfortable with. We also have Terraform if you need org-wide consistency across different multiple cloud providers. You can use that. The absolute rule would be never manually deploy Lambda to production ever, because it's untraceable, unrepeatable, and one bad deployment away from an incident. So you have to ensure that you're deploying it via any of the infrastructure as code services, SAM, CDK, Terraform, CloudFormation, whichever you're comfortable with. Then on the deployment strategy also, you need to choose wisely. So Lambda aliases are your best friends here. We have, let's say you have a live alias, which always points to a stable tested version. When you deploy a new version, you used weighted routing. Start off, let's say 10% of traffic to the new version. Watch your CloudWatch alarms. If error rate or latency spikes, you have to do automatic rollback. Um, and in case everything looks healthy, you can promote to 100%. So there is canary deployment where you can tell like AI changes without you have to wake up at 3 a.m. and solve those. So canary deployments are really useful in this case. There is a security and observability stack as well, which you can use. You need to have CloudWatch alarms, X-rays, metrics, and Lambda insights for memory and CPU, because you have to test the code in advance. It should not like there are any memory leaks or low memory cases happening. So these are the extras, but I would not call them optional, because these are super important whenever you're building an architecture like that. An extra slide on security, because there are the things which you can definitely use, and these are the things which actually gets printed on the walls in regulated industries. So let me call out the three things specifically. We have VPC endpoints for Bedrock. This is the one most of the teams miss. By default, your Lambda calling Bedrock goes over the public internet. In a regulated environment, that might be a compliance problem. So you can use VPC endpoint that keeps the traffic entirely within AWS private network. You need to have model invocation logging. Bedrock can log every single API call, input and output to S3 or CloudWatch. For any regulated workload, you want this on, and you can have tagging. So tag every AI resource with the project, team, and cost center. when your finance team asks why the cloud bill went up, you need to be able to show them exactly which AI workload caused it, because we don't know that it's just one API call being sent to the foundation model, or there are multiple in succession, right? It can be a recursive loop as well. So when you're actually building the agents in live production environment, agents can talk to each other. We are giving that privileges to the agents to talk to each other in the live environment. In case one of the agent is not behaving properly and creating a recursive loop, calling the foundation models again and again, there are n number of requests which is going out. So you need to be able to trace which part of your AI application, let's say you have hundreds of AI application, which part, which AI application failed, or and which part of that AI application, so that you don't have to redo the entire architecture, but just with tagging you'll be able to identify, okay, this are the kind of API calls which were constantly being high, and that's how you have to take care of that. Okay, with that, let's quickly move to the live demo. So let's spend some time here. This is the part I've been looking forward to. We're going to build something real. What we're deploying is a document intelligence API here. Let's say you upload any PDF, the system extracts the text, send it to the cloud on Amazon Bedrock, or let's say any other model which you want to use, gets back a structured analysis, the summary, key points, document type, the sentiment for that particular document, and then you can ask questions about that document in natural language, get grounded, accurate answers back. The entire backend is serverless. We are using S3, Lambda, Textract, Bedrock, DynamoDB, API Gateway, and all of this is deployed with a single CloudFormation template, which maybe later if can be shared as well. And this is how it's going to be built. Just remember, this is all serverless, so it's not that anything is, the cost is not applicable right now because we're not hitting anything, right? So it's pay as you go, and this is one of the use case which is very common across different industries. So that's something which you can definitely take away from today's session. Let's quickly get started. Before going to the details, let me quickly show to you the UI. So this is the application. We are just calling it DocIntel, where we have an API endpoint which we are connecting to. It's already connected. This is a sample which is already running, and it's deployed on real AWS resources. It's already running. It's connecting to an API gateway endpoint. The reason we are embedding this API gateway endpoint right here is this is a demo application. In real scenario, in prod environment, you are not going to ask the user for the API endpoint because it would be embedded. So we don't want it to be embedded or hard coded right now, because this is very specific. It is needs to be reusable. It's a demo. So in that case, we are just giving the API endpoint here. It's already connected. You just have to connect to it. We are connecting it because this is the interface to our Lambda functions and to other services as well. So we can just go ahead, upload any of the files we have. Let's say I upload this CI/CD PDF I have. There is a pipeline which is working. The file is uploaded. As soon as it's uploaded, it has given me the summary, right? So I'll come to details how it's happening at the back end, but it has given me the summary. It has identified the key topics and key points. Summary, it has given me the characters it has read, and the sentiment analysis. This is not something which is being let's say my UI is not categorizing these things. This is the format I have asked the backend model to provide. So I have asked that whenever the data is coming back from the model, I'm getting the detailed analysis of a particular document. It should be divided into these points, and then in the UI, definitely have added few of the components that it's a JSON. So whatever it's in the summary should be presented like this, key points like this, and topics like this. So this is how it's working. We have just uploaded it uploaded it to S3 for sure. And then there's a pipeline, there are documents. This was a previous document which was already there, and this is a new document. In the UI, I've also added few common questions which I might ask this, right? So this is a chat section which I've also created in this application, where let me ask what are the best practices mentioned. And these are not hard coded, these are just a sample questions for ease of the user, that they can just click on that, they can get the data out of it. But there might be other questions we need to ask. So let me ask specific question around, let's say, what is code commit? Let's see. Okay, so in this document there was details about code commit, so it was able to answer these questions, like it's a fully managed service and all those details. So this is what this whole application does, and this is a UI which is built, but in most of the prod environments there might be use cases that this is just part of the workflow, where you just have to get the data, do something, and then send to the user. But this is a user friendly UI which you can use, and this is completely built on serverless. So let's go back, look at the stack as well, and then I'll definitely show you how it has been built, and the code and other common areas. But let's quickly see one more thing before we dive it. This is what we have built. So we have an S3 bucket. As soon as I trigger the upload, the PDF file goes into the S3 bucket. There is a trigger already present in that S3 bucket, which actually sends, or you can say create an event, and then a Lambda function gets triggered. So here I'm using Lambda only as orchestrator, because I'm not using event bridge in between, because this is not a heavy use case where I need to use SQS event bridge and do other things to trigger. But for this particular event driven pattern, I am just using an S3 bucket which triggers the Lambda function whenever a PDF file is uploaded, and this orchestrator function actually coordinates the complete flow. It then calls texttract. So we have texttract APIs available. We extract the text from that PDF, then we send that text to Bedrock. Okay, so we pass the extracted text to Bedrock with a structured prompt, and it returns a JSON object which contains the title, summary, key points, the topic, sentiment, and the action items which I was talking about. Then we have DynamoDB and API gateway, where we are storing and serving the results from. So the results are already added in DynamoDB in the first go, and then we are returning it from there. Now, a sample Lambda handle I added here. There are bucket object where we are getting the events, right? So these are the event details. We are getting the details of the file which is uploaded. We are extracting the text using Amazon Textract APIs. We are analyzing that with Bedrock and storing the result in DynamoDB. So this is the standard workflow which we are using, and most of it is event driven in this particular case. Let's go ahead and look how this has been built. Let me show you the stack. So this is the AWS account, and you can see that there are multiple things here. There are templates as well. If you see, this is the template I have used. We have created IAM roles, we have created the Lambda functions, and that's why I was saying that infrastructure of as code is super important when you're building serverless applications. Anywhere, if you need to change anything, you can definitely do so. We have the managed policy ARNs. We are in specific policies on the S3 bucket and a specific account, specific extract permissions as well. And trust me, while building this, I have even got into multiple errors related to the permissions, related to course errors, because when you're building such kind of application, you need to allow course as well. And I'm using S3 static website hosting for this, where this is hosted as a S3 website. You don't even need to host it anywhere else. You can just use S3 website hosting if you just want to go ahead and create a demo of your own. So that's something which is being done. There is a Lambda configuration whenever an object is created with prefix as upload or .pdf as a suffix, this particular function is triggered. So that's the first part which I was showing, how an S3 bucket is triggering the Lambda function. There are bucket policies on S3. We don't want it to be fully public. We just want it to be called from specific clients itself. We have Lambda functions. There's a full-fledged code of Lambda functions, which I'll just show you in a minute, and few other resources like APIs, how you're building the APIs. There are different API use cases as well. If you see the resources first, it created an API gateway, it created Lambda role, Lambda function, then different API methods to be able to call. Then we have a DynamoDB table which was created. We have an S3 bucket, S3 policy is separate because these are two different resources when you use CloudFormation as well. So yeah, so that's how you can build it. In the outputs, I'm getting the API endpoints which can be used. I'm getting the bucket name. I'm getting like different details altogether for this particular thing. Okay, let's look at the Lambda function. There are few key things in the Lambda function which you should look at. How you are defining the region, whether you want cross-region inference or you want the models to be available in a single region itself. So that's something which you should check. Then course has to be allowed because Lambda is directly returning the response to my UI. And then there are different prefixes which can be present. There needs to be a signed URL which is then being used to get the document back and answer the questions. Those have to be checked as well. But a few important thing is this, how we are invoking the model. I have just defined the model ID in the environment variables in Lambda functions because let's say I don't want to use this particular model, I want to use something else. So I don't have to hard code or change my code every time. So that's why I'm using an environment variable where I'm putting the model ID. You just need to remember one more thing, that some of these models are need the specific input, the input in a specific format. So if that is the case, you might have to make changes into how the API is being called, how the input, you can say, context or the prompt needs to look like. So those are the things which really needs to be checked while you are defining this particular kind of AI application. If you see, there's a prompt I've mentioned for Bedrock, that you're an expert analyst, answer the question using only the document content below. So it's not referencing any of the outside content, and that's where we are reducing the hallucination as well, because we don't want the model to generate any of the new content on its own. We just want it to use our content, our document which we are saying, which we are providing actually as an input, and give the response from that. So you can definitely say it, and these kind of prompting techniques are super useful when you are actually building real applications. So if the answer is not in the document, just say I could not find that in this document, because by default the models which we are using, they have the ability to provide an answer, right? And even if the answer is wrong, they will provide you something. I think this is what we all have learned while using these kind of models, chatbots and other things since some time now. So we have to explicitly tell that don't say anything if you don't know. For example, let's say you are building an AI application for some kind of car lease policy for your particular organization. If you do not provide this kind of prompt, and if you don't say that you have to use a particular document only, do not make it up, it can get the car lease policies which might be public, right, outside for some other organization or in general. So can give the data based on that. But if we don't want that, we have to add it in the prompt. We have to supply those documents maybe as a RAG in this case, and then it should answer from that document itself, not a new answer generated which might not be true. So these are the things which we really need to be careful about, and that's how you can use the Bedrock API. And it's that simple. Within the Lambda function, you just have to write the code just to invoke specific APIs, give the model, give the prompt, and you will be able to get that. Max token, as I said, I've already set up, so it will not give me answers more than this particular token. So that's how it is. If you see, it's giving me a JSON in that case, and I'm just returning it as document title, model, and other things. So that's also something which is useful. There is another API as well, which is the another Lambda function, which is processor Lambda function, where I'm also verifying whether the document which is being uploaded is already processed or not. And this is being done for idempotency. I don't want any document to be chunked again, to be fetched again, extracted again for extract. So that's why I'm saving the duplicate API cost there. And to do that, I'm just using MD5 hash. So I'm creating an MD5 hash for that for every document based on the document details. Creating an ID which is unique, storing that in the DynamoDB table. Let me show you the DynamoDB table. There are different things. Yeah. If you see, there are tables in this table particularly. Let me do it. I uploaded a new document just in front of you. So this is the document ID, which is uniquely done. There was another document I uploaded, but there was no text in that. So it actually failed. I'm managing the status as well there, like whether it's completed, failed, what was the output, what was the key points in all of these. And that's how it's being done. Okay, I can show you the API gateway as well. This is the API gateway where we have different resources created. For options method, for course which is being created, we have a proxy method to accept any kind of request, right, for any of the UI path, and that's how it's being done. And that is about the demo. If you want, I can drag and just get one more document uploaded. We can ask some questions, and this is how the whole pipeline is working. The first Lambda function is actually trying to get the document uploaded, and then the second Lambda function is actually trying to assess this questions which you are answering or asking from the UI, and getting the data from the backend and supplying it. So that's how it's the whole setup is working. So this particular document contains some architecture best practices. We have data around AWS Lambda, how the serverless thing works. And let me ask a question. What is Lambda? So based on that, it is giving me the answer. Give me 2 best practices. Okay, so it has given me the answer for that. So these are not the predefined questions I'm asking. These are just a general question based on the data we have. Let me ask another question. Okay. So I've asked specific question related to ARM64 Graviton architecture. I just saw it here. So it has given me the answer. So definitely models are able to perceive and able to give us the answers, look at the document, do the indexing and other things, getting the most relevant answers. But building this is super important, and understanding how this is built at the backend layer is what makes the engineer smart, right? So we need to know that yes, chatbots are helpful, models are helpful, but where we are building it, how we are building it is as well equally important. So that's about the demo. There are a few more things which we can quickly cover, and then we can move on to the questions. There are a few production lessons where we actually have seen that we should take care of when we are working on serverless applications. These are the things that either caught me or caught the teams I've worked with, and I'm sharing them so you don't have to learn them the hard way. The first thing is the cold start problem, right? So when Lambda hasn't invoked recently, it takes extra time to initialize a runtime in your code. For AI endpoints where users expect fast responses, this is actually noticeable because they will have to wait for the response. So in that case, you can use provision concurrency for your latency sensitive functions. You can keep your deployment packages small, under 50 MB if possible. Then you can use containers. So containers image lambdas have longer code charts, so avoid them for real-time endpoints, but otherwise you can use containers as well. Then you have token cost explosion. This one catches teams off guard. So a single poorly written prompt that sends an entire document without chunking can generate thousands of tokens. So multiply that by thousands of requests, and your Bedrock will bill basically is suddenly very large. So you have to implement Bedrock prompt caching in that case. Use the model routing using specific model for specific use cases, and always set the max token. Super important. You might have seen in the code, I have also set that max token that way. um, Lambda can timeout, so you have to ensure that you don't set the default timeout to 3 seconds, and that's when there is templates or infrastructure as code, and the SAM local testing will help whether it's failing in within the default timeout or not. The inference can take time, so you have to set that accordingly. You should use a async pattern. Get the 202 immediately. The process can happen in the background. It can put it in the DynamoDB table. You can just pull it later, right? So that's how it can help. Idempotency is also important. As we saw that Lambda can be invoked multiple times, and it has an at least once option in case of async. So you have to store the process request IDs. You have to uniquely identify each of the requests so that it's not duplicate. Then security patterns, you should use API keys, secret managers can help there. Never use wildcard. Never give your Lambda function a wildcard permission where it's able to access all the other resources within your AWS account. It might backfire in most of the cases. So there's a real risk related to that. And let's say you are building this on production, it's super important to have observability into place. Uh, have the architecture ready. Structured JSON needs to be there. You have to add all the lambda invocations. You have to check for the metrics, the AI quality. There are specific AI metrics as well available. Textract has its own metrics. Bedrock has its own metrics, but if you want also any of the custom metrics, that's also something which you can create as a model monitoring framework. Just going a bit deeper on the pattern side and on the whole security side, for more experienced folks in the audience, I just want to touch on 4 areas that come up when you move beyond the basics, right? So, what is fine tuning and how is it different from prompting? The honest answer is prompt engineering covers 80% of the use cases, right? So, and it's faster, it's cheaper than the fine tuning. So, you should start here. When you combine RAG with prompt engineering, you get a good knowledge based scenarios, and you'll be able to cover that. So you don't need fine tuning exactly in that case. So fine tuning becomes what? When you have very domain specific vocabulary, let's say medical terminology, legal language, proprietary jargons, sorry, where the base model consistently gets things wrong, and despite good prompting, you're still not able to get the data. So in that case, you can use fine tuning. Guardrails and responsible AI, non-negotiable in production, especially in regulated industries. Bedrock guardrails lets you define the content filters which you have, like PI detection policies, topics restrictions that apply before and even after the model invocation. In Bedrock, we have that as well. So you can just go ahead and look at that. For medical recommendation, financial advices, you should design such that we have human in the loop checkpoint so that nothing goes out of hand in that case. Then we can have a DR strategy, multi-region for sure. Bedrock model availability is not uniform across all regions, so you should check before you design. If you want disaster recovery and your model need to be available across different regions, you need to check. So you can check whether your model is available and if it supports inferencing in different regions before choosing a model. Then DynamoDB global tables, it gives you active multi-region for state, Lambda and API gateway deploy independently per region. So you need to see how you are using Route 53 to do the latency based routing, or you want a CloudFront in front of that. So that's how you can divide different layers of orchestration and pipeline for your AI application, and which will help to run it longer in productions. Then performance engineering, Lambda power tuning is something which I have felt is really useful. You can optimize the memory, the cost, and the speed curve. Connection pooling, declaring in more to 3 clients outside the handler. Then there are Bedrock streaming APIs which you can use, which can help in the UI part, that how user is perceiving the response from the Bedrock. So that's something which can be checked. Then we have SQS batch size tuning, the Lambda concurrency and other things which can be checked and can be very well managed in that case. Okay, quick takeaways. And an action checklist for you all. You can start with one serverless AI use case, right? Just pick one. Don't try to migrate everything to serverless at once. Just pick one API endpoint or a batch job that has a bursty traffic. You have to remember for what you are using serverless for. Move it to Lambda and Bedrock. You can measure the cost difference after 30 days. The numbers will definitely make the case for the next use case. So just go ahead and you can start with that. Second, you can enable Amazon Bedrock in your AWS accounts today if you haven't already. You just have to go to the console. You can request access. I have seen that for few of the Claude models, you just have to fill a form for the use case. For others, I think they are actually readily available. You don't have to explicitly go ahead and request anything as such, but definitely go ahead and check that out in the AWS account. And these models are genuinely capable. You can do a lot of these things. You can automate a lot of workflows for your own teams using these models. Just run or create a serverless application and you're good to go. Then you should start writing an infrastructure as code from day one. It just takes a little bit of time. It's just 15 minutes. So you can use AWS SAM. Just define the Lambda function name. You need what you need it for, the API gateway you want it to connect with, the S3 buckets, the DynamoDB and other things. And the investment actually pays back every single deployment for the life of the project. So again, never manually deploy Lambdas to production. Always use infrastructure as a code. The reason is, let's say if a Lambda function fails, you have to roll back something or you have to do any of the update. The manual updates done on the console will not be reflected. So you have to ensure that you do it via infrastructure as code. You can push it to a CI/CD pipeline as well, and that would be pretty useful. Fourth point, design AI workloads as async. That's also super important because just return to O2, process that in the background. Your users will thank you for sure, and your on call will thank you as well, because if it's async, it will be processed sooner or later. It's not like that you will start getting the errors. If it's not able to accept the traffic itself, then there's a problem which definitely has to be solved. But definitely async workloads, my eyes, are better for AI systems. And implement the model routing. You have to first classify what is the use case. Are you generating embeddings for that? Are you extracting the text? Use textrat. You don't need any specific model there. Are you analyzing the text for something else? Are you analyzing images? The type of data you're analyzing, that also matters. If you have a combination, you might have to use a multi-model approach. So those are things which you need to take care of. Then the observability is also super important, which needs to be part of this whole framework, whole pipeline, and that's where the actual magic starts. You will be able to see the drift. For example, the data you provided, how many were the good answers, how many were the bad answers, whether the data changed. So when you are actually building this in production, you will have to see whether the type of request coming from the user has changed or not. Let's say the user has started giving not PDFs but some kind of Excel files. So those are the drift metrics which you'll have to capture somewhere, and based on that you can keep on improving your whole AI infrastructure and the whole model, and that's how it will take care of the rest of things. Quickly going back to the application, and just one more thing, that this is not a single workflow which is doing everything. We have event driven architecture where we are uploading the files, it's getting the file, we have the serverless components, the APIs connected to it, then we are using S3 and DynamoDB to get that document back. If you're seeing refresh, these are the documents. If I go back to my DynamoDB table and let's say I delete all these, in this case, if I go back, refresh, I think this one is still getting deleted. So we will not be able to see that. So those documents disappeared. So this is directly connected to my DynamoDB table. So this is how I'm refreshing the documents which I have, and this is the whole pipeline. So all the components are being used for multiple use cases. There are two Lambda functions. There are one DynamoDB table, one S3 bucket, S3 website hosting where this whole UI is residing on. There are bedrock models. There is a text tract which is extracting this test and giving me the topics, the key points, the summary, and all of these details. If I upload any of this file again, let's say this one, the pipeline starts running. So it's independent. It's how the real production systems work, and how you can actually create an interactive AI application all at once using serverless. I think with that, I will like to conclude the session for now and open for questions. There are a few resources which we want you to bookmark, like we have the surveillance pattern library, we have the Bedrock official docs, Lambda power tuning docs, the SAM getting started, and also the AWS cost estimator, like we have the AWS cost calculator. So these are the resources which you can look for when you are starting to build anything on AWS serverless resources. I would genuinely love to see what you build from here. And if you deploy something based on what we covered today, share it, tag me on different channels, and we can connect on LinkedIn, and we can feature any of the project and continue the discussion. On the personal note, just it's International Women's Day, and to every woman on this call who is building, learning, or leading in tech, you belong in this space. The field is just better because you're in it, and let's keep going and keep learning. Thank you so much for your time and energy today, and brilliant session. Over to you, Aditya, for any questions we have received in the chat.
Yeah, thank you, Pallavi. We have few questions. The first question is this, that if I want to work at the intersection of AI and cloud, what skills should I focus on?
Okay. Very nicely taken. I think this was one of the questions I had back when I was starting with AI and cloud things. The main thing to understand is we cannot escape AI right now. There are a lot of new things coming day in, day out. In the morning, you hear of any model, at the night, there is something new, right? So these are the things which are evolving right now a lot. So, for let's say if you are a new professional, in that case, just start with cloud basics, and serverless is a very cool area which you can start with, right? Just start with serverless on the cloud. AWS has a lot of tutorials available. There are a lot of serverless land patterns. You can start, get an AWS account, register for free tier, get started. And as I showed, right, AI and cloud, this is the combination which is not going anywhere. For any AI application built, we need an infra, right? Where are we going to host it? There are a lot of new applications coming in, new you can say tools coming in. Where are those tools hosted? On cloud. So all of this is in cloud. Let's say you have an idea as well, that's also something which you can build and deploy on cloud. So I would say, now summarizing what I have said right now is, start with cloud, right? You cannot escape AI, but once you know the fundamentals, you will be able to intersect between these two. You'll be able to call the models. So you don't have to learn maths, you don't have to do the heavy work. I think that has the time has gone for that. And you just have to understand what is the use case, where you need to build it, and how and what kind of models you need to use. So that's how you can intersect and start building on the cloud. And I think, feel free to ping me anytime for any kind of help. Yeah, I hope that answers.
Thank you, Pallavi, for answering that. We have another question, and that question is, are there any scenarios where serverless might not be the best fit for AI workloads?
Yes, definitely they are. Let me quickly turn that back as well, where we should not use serverless on the slides as well. Let's say you have a workload which has to run continuously, right? You have a very high user base, there's a constant load, it should never drop. In that case, instead of doing multiple calls, right, for serverless spinning different serverless containers, you can just use ECS or EKS if you're familiar with containers. If you just want to get started with containers, you don't know about Kubernetes, just get started with ECS. That's a pretty useful service to get started with containers. You can use those kind of alternatives. um, if you want to train the models, serverless is not a good choice because it cannot. So the custom model weights, the packet sizes, the limitations to the amount of code, when you're training the model, it's a huge code, right? You have to apply a lot of different compute capabilities, the instances, GPU, TPU, so you need those kind of heavy instances to perform the model training in a better way. So in that case, you can go with SageMaker. It gives you a very good interface to quickly bring your own model, just start training it, do the pre-training, and that will solve your use cases. So in these kind of things, serverless might not be a good choice, but for, let's say, to solve different bits and pieces of a bigger use case, you can definitely use serverless, where you do not need a high throughput or constant load forever. I hope that answers.
Yeah, thanks, Pallavi, for answering that. I do have a question. I think we already had two questions from the audience, but I have
Mhm.
one question for you, and that is like, how do we decide when to use Lambda or container-based services like ECS or EKS
Okay.
while building the serverless AI applications?
Okay. So when we're talking about
Yeah.
AI application, the first thing is who is going to use it, right? Who are your users? And second thing is, to be honest, what are you familiar with? When we are talking about enterprises, definitely we have very huge workloads. We don't want any inconsistency, we don't want any cold starts to happen, the request flow has to be seamless. We are also worried about the cost. Let's say you are working on a use case which is event driven, right? It's not something which has to run throughout the day. So in that case, you do not need EKS or ECS. And to be honest, EKS, ECS, and the containers, it's not something very easy you get started with. But with Lambda, you're getting a managed service. Just bring your code, anyone can get started with it. Just bring your code, put it on Lambda, use the CloudFormation template as I have shown, and then go ahead. You can start working on it. So these are the things which will really help you to bring an idea to production, right? From idea to production, to bring it fast, you can use that. Another thing is with EKS, for a controlled environment. Let's say you are building a platform where you want to keep everything at one singular place. The platform is doing a lot of different things. In that case, go ahead with EKS. It's not a standalone event driven use case, but it's a big platform which is an AI platform doing a lot of different things. In that case, you can use EKS as well, but it should not be a blocker. I think there are a lot of different use cases which can be built both on EKS or serverless Lambda. So that's how you can decide.
Thank you, Pallavi. That answers my question. So that's all, Pallavi. We only had these three questions as of now, but we do have some compliments from the participants on your work. So you might see those on a screen. We have a compliment from Anirudh. Very nice, well-written slides. Another one is excellent content, and another one is looking forward for more such sessions. So thank you so much, ladies and gentlemen, for such a great participation. And that's all, Pallavi. Do you have anything else to deliver or say?
No, I think thanks a lot for staying for the session, staying till the end. And I hope the demo and gave you some clarity of how we can actually bring different serverless services, different AWS components together, use Bedrock. So I hope you will start building a lot of AI models and AI applications from now, and just start tagging me, and then let's make, you can say, a lot of different AI applications which are actually solving the real world use cases. So happy learning and have fun.
Thank you so much, Pallavi, for such an insightful and engaging session. And I'm sure that everyone here learned something valuable today about building serverless AI applications on AWS. And once again, ladies and gentlemen, uh, on the occasion of International Women's Day, it's inspiring to see leaders like Pallavi contributing and guiding the tech community. And I would also like to thank everyone who joined us today and participated in the session. If you enjoy this session, please stay connected with AWS User Group Dehradun on Meetup and LinkedIn, and I'll share the details on the email. And just to let you know that we regularly host sessions and workshop and discussions around cloud and AI and modern technologies. We look forward to seeing you again in our upcoming events. And thank you everyone for joining. Have a great day ahead. And once again, wishing you all a very happy International Women's Day. Thank you so much.